So, dear students, today I am going to discuss about the first chapter of physics, and this chapter is related with your class 11, and which is unit, measurement, and dimension. The name of the chapter is unit, measurement, and dimension, and dimension. So first chapter of the physics. So unit, measurement, and dimension. This very important chapter because in your CEE exam some questions will come from this chapter. So now see first what is the meaning of unit. So unit basically is a kind of indicator by which identify the physical quantity. So physical quantity basically it is represented by mass, length, time, velocity, acceleration. These are the physical quantity. So unit, you should know, unit means a kind of identification. You see, suppose mass, I am writing mass. Mass means it is represented by kg. So when we are talking about the kg, it represents the solid body. So when I am talking about the length, it is represent meter. Meter means unit of length. So how much distance traveled by an object, that can be represented by meter. So when I am talking about the liter, then it represents liquid. So this is basically unit. Unit means a kind of identification factor which is used to measure the physical quantities. That is why it is called unit. You remember basically there are different types of unit. One is SI unit, another is CGS unit, FPS unit, and System of International Unit. Among all the four units, you remember basically in physics, CGS unit and SI unit is very important. So in physics, basically all the problems are given in terms of SI unit, that means System of International, and CGS unit. So SI unit, you should know about the SI unit. SI unit, this is called System of International. That means all over the universe, the system is remains same everywhere. So that is why it is called System of International. Suppose meter. Meter is the unit of length, and meter per second unit of velocity. So everywhere in the universe it is remains same. So that is why it is called universal constant value. That means unit is a kind of SI unit is a kind of common value everywhere in the universe. So this is the idea about the unit. Now measurement. Measurement means length can be measured with the help of meter. Mass can be measured with the help of kg. So that is why measurement is required. So depending upon the quantity, we can use the SI unit and we can use the measurement. So this is very important. But you remember in this chapter basically two concepts are there. One is your error. You should know about the error. Error part is very important. Errors. This is called errors. And another part is dimension. Error and dimension. You remember, first I will discuss about the error. So error is very important topic. So first you see error. So when I am talking about the errors, these represent what is the meaning of errors. Error means basically actual value minus measured value. Suppose if you consider one object, any object manufactured by company. So here given suppose 20 kg. So when you want to purchase this object and when you measure practically, then you are getting suppose 19.5 kg. So this 20 minus this 20, it is called actual value, and this 19, it is called measured value. So the difference of actual value and measured value, it is called your errors. So you remember error means actual value and measured value. So in your C syllabus, basically error we have to discuss in terms of percentage error, in terms of relative errors. So basically you remember errors there are different types of errors: human errors, instrumental error, scientific error, then relative error, percentage error. But I am going to discuss only errors. in which actual value and measured value measured with the help of percentage error and your relative errors. So first you see, basically there are 6 types of errors, different types of errors, but mainly 2 types of errors are very important. Number 1, you remember relative errors, relative errors, relative errors. Number 2, percentage of error, percentage of error, percentage of error. So relative error and percentage of error very important. So how we can find out the relative error, how we can find the percentage of error. So first you see, when we are talking about the relative error means, suppose, what is the meaning? Suppose first I am discussing relative error. You can see relative error. Suppose we have given one function, suppose z is equal to x square y square like this. Z square it is given like this. Or you just consider suppose p. So you remember p is equal to x square y square it is given. So relative error in relative error in p, delta p divided by p is equal to, you remember, 2 delta x divided by x, 2 delta x by x, and here plus 2 delta y by y. So this is called relative error. Actually the function it is given, p is equal to x square y square. So this x square y square can be written in terms of relative error, delta p by p is equal to 2 into delta x by x plus 2 into delta y by y. So this is called relative error. So when this term we can express in terms of percentage, you remember percentage of error we can write, percentage error in p we can write delta p by p multiply 100 is equal to 2 delta x by x multiply 100 plus 2 delta y by y multiply 100. So this is called percentage, this is called percentage, this part it is called percentage. That means percentage error in p, percentage error in x, percentage error in y. So first you see, I am going to discuss one numericals. You see how you can calculate the percentage error. So this is the example. You remember p is equal to x square y square. This is a function, and relative error, that means what is the relative error in p? So it will be delta p by p is equal to 2 delta x by x plus 2 delta y by y. So in case of percentage of error in p, so you just multiply both sides with 100, then it will be converted into percentage of error. So now see, you remember the questions will come like this. So suppose question, I am discussing one question. Suppose the percentage error in length and time are the percentage error in length and time are of a simple pendulum simple pendulum are 1% and 2%. That means percentage error in length and time of a simple pendulum 1% and 2%. What is the percentage error? The percentage error in acceleration due to gravity, acceleration due to gravity, acceleration due to gravity. The percentage error in acceleration due to gravity is option A 1%, option B 2%, option 3 3%, and option D suppose none of this. None of this. So this is the question. Simple questions I am going to discuss here. The percentage error in length and time of a simple pendulum given as 1% and 2%. So what is the time? What is the percentage error in acceleration due to gravity? Now see, this is the question. So how we can solve it? You can see here given percentage simple pendulum percentage in length. That means this length is given 1%. Time is given here 2%. So we can write here delta L by L is equal to 1%, it is given, and delta T by T, it is given 2%. Now we have to calculate delta Z by Z is equal to question mark. So we have to calculate the percentage error in acceleration due to gravity. Now see, there is a one formula. So how we can solve this problem? So you just see the solution. So solution, already you know T is equal to twice pi under root L by Z. So I think you have idea about this formula. This is a time period of a simple pendulum, and here T is a time and L is a length and Z means acceleration due to gravity. Now see, from the given formula we can write T square is equal to 4 pi square L by Z. After squaring both sides, then we can get T square is equal to 4 pi square L by Z. So our target to calculate the percentage error in acceleration due to gravity. So that is why this value will come left side. So it will be 4 pi square L by T square. So you remember in this case, first you have to express this relation in terms of relative error. So relative error in Z, delta Z by Z is equal to 4 pi square is a constant. So it will not work. That means it is a constant. So it will be delta L by L plus 2 into delta T by T. So already you know about the properties of error, which is given in class 11. So now you can see multiply with the help of 100%. Here also delta L by L multiply 100% plus 2 into delta T by T 100 multiply 100. So according to our question here given length is it is given length is 1%, and here 2 multiply this time it is given 2%. So ultimately we are getting 1% plus 2 into 4%. So it will be 5%. So you remember percentage error in acceleration due to gravity, you remember 5%. So answer will be 5%. So option will be none of this. So in this way we calculate the percentage error, right? So this is very important topic. So relative error, if it is given relative error, then we have to calculate the percentage error also. For example, you can see this is the textbook example I am going to discuss. You just see here, that means what is the percentage error? What is the percentage error? Suppose you just see, we can consider in case of potential and electric current, V is equal to IR relation. So you just see, normally V is equal to IR already. This is the formula. Suppose one question is given related with this. If I is equal to 10 plus 0.2 ampere, it is given, and R it is given, suppose 5 plus 0.1 ohm. So unit of resistance is ohm, already you know, and current is ampere. So that is why we can write ampere A like this, and resistance, that is why ohm. So in this case what we'll do, here you remember this I is equal to 10 plus 0.2 ampere, R is equal to 5 plus 0.1 ohm. It is given. So now find the percentage error. Find the percentage error in potential. Potential means potential. Potential means V. Find the percentage error in potential. So what we'll do? Solution. You remember. So potential means already you know, V is equal to IR. So this formula you have to write in terms of relative error first. That means relative error we can write delta V by V is equal to delta I by I plus delta R by R. So this term can be expressed in terms of relative error. Now what we do is just see from the given relation here. I it is given 10 ampere and delta I it is given 2.2 ampere. In this case R it is given 5 ohm and delta R it is given 0.1 ohm. So just you put the value here. So you can see delta I means 0.2 and I it is given 10 plus delta R it is given 1 and R is given 5. So this can be written as like this, 2 by 100 plus 1 by 50. So here also 1 by 50 we can write plus 1 by 50. So is it 50? So it will be 2. That means 1 by 25. So now see, you just multiply, therefore delta V by V multiply 100 is equal to 1 by 25 multiply 100 percentage is equal to 4%. So find the percentage error in potential. That means percentage error in potential will be 4%. So in this way we can easily calculate the percentage error if error is given to you. So last one question I am going to discuss about this error. After that I am going to discuss about dimension. So first you see, suppose you have given length is given and breadth is given. So what is the percentage error in area? So question, in the given question, suppose given, if L it is given, suppose 5 plus 0.2 meter and breadth it is given suppose 3 plus 0.1 meter. So what is the percentage error in area? What is the percentage error in area? Percentage error in area. What is the percentage error in area? Now solution you can see as earlier. You remember here L is given this part, that means L length is given 5 plus 0.2 meter and breadth it is given 3 plus 0.1 meter. Okay. Now you can see area, we have to calculate the percentage error in area. So what we will do? So first you find the value of L is equal to 5, delta L is equal to 0.2. It will be in meter, and here B is equal to 3 and delta V will be 0.1. So all the terms it is given, it is a distance, so that is why we can write in terms of meter only. So now we have to calculate the percentage error in area. So basically this is a kind of rectangle, length and breadth is given. So what is the area? Therefore area we know that length into breadth, this is the given formula. And now see, area is equal to length into breadth. This formula you have to convert in terms of relative error. So what you do? Delta A by E is equal to delta L by L plus delta B by B. So this part I have written here according to the properties of error. So now is just put the values. Delta L means 0.2 divided by 5 plus delta B means 0.1 divided by 3. So this term we can write 2 by 10. So here 10 will come. So it will be 2 by 50. 2 by 50 plus 1 by 30. So you can see what is the calculation part. You can 50 and 30 take the LCM. 2, 25, 2, 15, and here 5, 5 and 5, 3. So 2, 5, 10, 10 into 3, 30, that means 30 into 5, 150. So the LCM will be 150. So 50 will 3, 6, 30 will be 5, it will be 5. So 11 by 150. This is the value of delta A by A. Now we are going to convert into percentage of error. So that is why delta A by A multiply 100 is equal to 11 by 150 multiply by 100. So this cancel. So it will be 1110 divided by 50. So this is the percentage. So when you divide this one, 110 divided by 15, what is the result? So you can easily calculate this result. That means this is the percentage error of the given question. So in this way you can easily calculate the value of percentage of error from the given data. Now let us come back to the main topic of the chapter, which is dimension. Dimension is very important because you should know about the dimension for each and every quantity which is related in the physics. So before you start the dimension, you should know about some basic conception of the dimension. So you have idea. Suppose x, I have considered one x. X is a variable. X is a variable. So I am going to discuss about the dimension. First you see dimension. So first you see, before you start the giving the definition, I am going to start about the basics of the dimension. You can see here I have considered here x, right? Now x is a variable. So when I am writing here 3, so x to the power 3, this means x is a base. X is a base. And 3 here it is power. 3 here power. So base and power. So dimension means it is the power of fundamental quantities. So you remember what are the fundamental quantities in physics? There are 7 types of fundamental quantities in physics. You should know. So first I am giving the definition of dimension. So you remember, dimension means it is the power of fundamental quantities. Dimension means power of fundamental quantities. So what are the fundamental quantities? So you remember fundamental quantities. Fundamental quantities are basically number one, you remember mass. Mass, it is represented by m and unit is kg. So this is the number one fundamental quantity. So mass always considered as fundamental quantity. So what is the meaning of fundamental quantity? The quantity which is very important for derive any formula in physics, it is required. Number 2, here length. I consider here length basically represented by meter. Length it is represented by L and basically represented by meter. So mass, length, fundamental quantities, and here mass, length. Number 3, time. When we are talking about the time basically it is represented by T. T means second. So these are the representation and these are the units. Now number 4. So mass, length, time is over. Next electric current. Electric current. Electric current basically it is represented by ampere, that means E. Ampere. Ampere. It is represented by E. Number 5. Number 5. So mass, length, time, electric current, then intensity, intensity basically unit of intensity is candela, so it is represented by CD, candela like this. And number 6, you remember mole, number of moles, so it is basically represented by ml, that means mole. So number 7, you remember temperature. So temperature basically it is represented by Kelvin. So Kelvin, that means Kelvin. Okay. So these 7 are the basics fundamental quantities you remember in physics: mass, length, time, ampere, candela, mole, and Kelvin. So these are the fundamental quantities you always remember. Now using this we are going to find the dimension. So I told you that dimension is the power of fundamental quantities. So here you can see dimension is the power of fundamental quantities. What are the fundamental quantities? Fundamental quantities are basically mass, length, time. So among these quantities, these values, that means this mass, length, time, ampere, candela, mole, and Kelvin. So these are the fundamental quantities, and dimension means power of fundamental quantities. Suppose 2, 3, 4, anything, this is the dimension. Suppose I am writing here b to the power 6. You remember dimension of b is not 6 because b is not a fundamental quantities. Okay. So dear students, you remember that means only these 7, that means 7 values: mass, length, time, ampere, candela, mole, and Kelvin. So if there is a power, then only we can say this is the dimension. But in case of other alphabet, in case of E, in case of suppose C, Z, these are not a fundamental quantities. So that is why we cannot consider there is a dimension. So our definition of dimension means power of fundamental quantities. So these are the fundamental quantities. If there is a power of fundamental quantities, then there is a dimension.